Hi everyone, Andrew Symes, I'm CEO and co-founder of OXCCU. 31 times, we're going to try and make it even bigger this time. Right, here we go. Sustainable jet fuel from waste carbon. Why do we need this? Everyone wants to fly more and more and more. The numbers are absolutely insane if you look at them. Every single year, people want to get on more and more planes. In order to stop the emissions effect from that, we need sustainable aviation fuel. We can make progress making planes more efficient, but you still need a huge amount of aviation fuel. Current predictions are that we need 450 billion litres. We currently make 0.1 billion litres. We only currently make sustainable aviation fuel from waste oils and fats, and there's just not enough of it. Everyone knows that, so we've got to think about new ways of making sustainable aviation fuel to solve the big issue of climate change. What you'll see over time, actually, is that aviation will become a bigger and bigger proportion of emissions. In the UK now, aviation emissions are actually higher than those from electricity already, and that will be set to increase as people want to fly more. It is actually taking off, Saf. There's a huge amount of investment going in on the left, and you see these real mandates now in the UK, in the EU, across Asia now we've got mandates. We're expecting China to put in a mandate this year. This is actually one of the biggest markets created in energy in the last 20 years. The size of it is absolutely extraordinary, but there is a challenge. The challenge is cost. Currently, we are limited by both feedstocks, but also cost when we get to the feedstocks that are actually scalable. And there's two reasons really for that. The first is the high capital cost because you've got multiple steps in these processes. The second is the high operating cost because you've got high energy input into these processes. And that's where we come in. Essentially, what we have is a technical solution that was invented by Tianqin roughly in 2010. So it was a long time in the making. And it's actually very fitting that we are in the Royal Society of Chemistry today. 250 years ago, the basis for all heterogeneous catalysis, which really all industrial chemistry is based on, was invented here by Humphrey Davy, who showed that by passing gases over catalysts, metal catalysts, you could get these amazing transformations. It was then the Germans, actually, who then took it further, and they invented Fischer-Tropsch in the 20th century. We're bringing it back to the UK in the 21st century, and with a twist. This time, we're not going to have the same impact on the climate. So the key thing is that we are focused on waste carbon as our feedstock. And what you find when you have waste carbon as your feedstock is that you need to convert carbon dioxide, not just carbon monoxide. And what we have here is something that people didn't think was possible, that you can feed carbon dioxide and hydrogen over a catalyst. This is the catalyst here. And you directly make fuel. This is the fuel here that we've made directly with CO2 and hydrogen. Everyone else thinks that you have to go first via what's called reverse water gas shift, make carbon monoxide, and then essentially do the Fischer-Tropsch. What we've shown is that Fischer-Tropsch is not essentially done. There is more innovation needed. And what we can do is essentially cut the cost of the fuel by essentially reducing the number of steps. We've got less steps, less capital cost, and also reduce the operating cost because it's a more energy efficient process. I won't go into the details here, but essentially we've got wide applicability to a range of different feedstocks. It doesn't have to be pure carbon dioxide and green hydrogen. It can also be waste wood. It can also be biogas. The pathway to scale is this, and I've been told that actually that plane trajectory is not correct. Apparently that's quite dangerous, but our trajectory is, that kind of trajectory. We still, as I say, the research goes back a long way. But ultimately, we got going really in 2021. 2023, we raised our first round, and then recently this year, we closed our Series B. We then essentially are quickly going to then think about our first commercial plant. Essentially, the scale, what we talk about is OX1, OX2, OX3. OX1, we delivered on time and actually under budget. It's at Oxford Airport. It continuously and is producing today roughly a litre a day of fuel. We've ran it already for thousands of hours. OX2 is around 1 to 3 tons a year, so it's around 30 times bigger, and essentially it's fully integrated. It has the ability to get very, very high yields. OX3 is really where we're thinking about our first commercial plant. This is our plant. You're very welcome to come visit us. We're in Oxford Airport, and actually there's a huge amount of innovation that's going on there. When we think about our actual commercial plant, we are looking globally, and this is what we really say. There's a lot of doom and gloom at the moment in the European chemical sector. It is grim. Lots of plants are shutting down. But the key thing that we are showing is that innovation in Europe is still there. And Europe can play a massive role by inventing the new catalyst that can be exported globally around the world. So we don't always have to think of us as being the largest producer anymore. That is potentially unrealistic. But what is realistic is that with our great innovators, with our incredible universities, we can invent the catalyst that the world needs. So we are genuinely thinking globally around where these plants are going to be. When we think about the business model, ultimately it's selling catalysts, it's selling reactor designs. Those companies you see at the bottom are extraordinarily valuable companies. Maybe they're not as well known as the BPs and the Shells of the world, but these are the companies that provide all the catalyst reactors that they rely on. They're incredibly valuable businesses, and we need to move them into essentially the new world, which is not based on oil and gas, but is based on waste carbon and essentially converting that into the same products that we need, specifically aviation fuel, but also chemicals and plastics. A lot of other things can be electrified, but those three sectors, chemicals, plastics, and aviation fuel, will never be fully electrified. You need a hydrocarbon. This is our Series B. We've got one of the largest refiners in Central Europe, Orlen. We've got one of the largest aerospace companies in the world, Safran, and we've got one of the largest airlines, IAG, which owns British Airways and Iberia. IP Group have been there right from the beginning. We would not be here without IP Group and without IP Group's backing. Clean Energy Ventures as well, Dan Goldman's here in the room. They've also played a crucial role, and we've also got Eni, Aramco, and a number of others. So we're incredibly grateful for those companies that have backed us, and we're focused now on delivery, getting our next plant done, and then ultimately getting as fast as possible our technology into a commercial scale plant. Beyond jet fuel, there's actually bigger opportunities as well in chemicals and plastics, and also e-gasoline for those motorsport fans that still will want it. So thank you very much. That's us, and please come and see us afterwards.